Fresh, green, and crunchy. That's how beans should be. But as an open field crop, beans face a number of adversities. Diseases such as anthracnose, which is transmitted by fungi, bacterial infestation with halo blight, and the bean common mosaic virus can lead to high yield losses. That's why breeders like Gerthon van de Bund are working on developing resistance to common diseases in beans.
Yield is the most important breeding goal for us, but also resistance to diseases. Because of high level of disease resistance makes it possible to increase yield indirectly.
Ease of processing and harvesting, as well as taste, freshness, and shelf life are further key breeding goals. As climate change progresses, tolerance to heat is becoming more and more crucial.
Constant high temperatures above 32 degrees can also cause problems for beans, especially if the night temperatures don't drop below 20 to 22 degrees for a longer period.
Continuous heat stress has a negative effect on reproduction. Damage occurs as early as 5 to 7 days before flowering during pollen formation. This leads to the formation of abnormal pollen, which prevents pollination.
And without pollination, the pods will fall off, resulting in very low yields. If maximum temperatures are too high, yields can decline from about 15 tons per hectare to about 2 or 3 tons per hectare.
Similar to beans, other crops such as tomatoes also suffer from high temperatures, negatively affecting their pollen formation.
Drought tolerance and heat tolerance are important components of yield conservation. It's a big challenge to affect these complex interrelated traits through breeding.
Moreover, heat and drought often occur in combination and can amplify each other.
Dry conditions can actually increase damage caused by heat. If there is a persistent lack of water, the growth of the plant can be slowed down. The leaves of the plant turn brown or burn. The yield decreases and the taste also changes.
One major difference is that drought can be compensated by artificial irrigation. But there is hardly anything that can be done about heat in open fields. Heat stress can therefore occur even with proper irrigation.
To develop beans with improved heat tolerance, we perform open field trials in combination with greenhouse trials. The most effective way is to choose a selection in hot conditions.
From the initial crossing to the final commercial variety, it takes an average of 6 to 7 years to breed a new, improved bean variety.
Genetic diversity is crucial in plant breeding, in particular in breeding for disease resistances. We mainly use elite line and commercial varieties, but also exotic material such as land races, where the interesting traits are present.
However, the genetic basis is quite narrow in some segments. Breeders address this by crossbreeding beans with other types for which more genetic diversity is available.
Molecular markers are becoming increasingly important in bean breeding. They make it easier for us breeders to use DNA sequences to track certain traits while learning from other crops like soybeans.
Markers for monogenetic traits are already common.
The next challenge is to find more and better markers for complex traits as heat tolerance.